Hello, this is Dr. Hanaa Assil and this is IGCSE Chemistry, and today we're talking about states of matter, solids, liquids and gases. So let us take a look at the difference between solid, liquid and gases. If we look at how particles are arranged and the separation between the particles and the differences in the movement of the particles. So if he's asking about separation of particles in a solid, remember that particles in a solid are closely packed, and that means they are touching, they are very close to each other. In liquids, the particles are near to each other. So remember that if he says draw the particles of a liquid, some of them should be touching and some of them not touching. But they are not too far away and they're not too close to each other. So we say they are near each other in clusters. What about particles in a gas? You should realize that particles in a gas are far apart. Please pay attention. What is he asking about? If he's asking about separation, then this is what we should say. But if he's asking about arrangement, how are particles in a solid arranged? You should realize that in a solid, the particles are in regular rows. What about in a liquid? We say they are in random arrangement. Or sometimes we say irregular arrangement, but random arrangement is a much better one. And gases also, the particles are randomly arranged. What about movement? So please notice, is he asking about arrangement or movement? If he's saying movement, how do particles in a solid move? Please do not say they don't move. All particles move. But the difference is, in solids, they vibrate in fixed position. The particles in their position are vibrating. For a liquid, the particles move around each other, or sometimes we say they slide over each other. In gases, it's fast, free, random motion. Remember that if we're talking about movement, the particles of a gas move faster than liquids and solids. Also, if we're talking about energy, the energy in gases, in the particles of a gas, is much higher. So the particles in a gas are the ones that have higher energy. What if we're saying which one is compressible? You know that compressible means which one can we press the particles nearer to each other. Of course, a solid, the particles are already touching each other, so they cannot be pressed anymore, so they are not compressible. In liquid, we also say that particles in a liquid are not compressible, but the particles in a gas originally are far apart, so it is compressible. You can press the particles with under pressure, the particles will come nearer to each other. Which of these has a fixed volume? Of course, solids have a fixed volume. What about liquids? Yes, they do. They have a fixed volume because the amount of water you have in a bottle, if you pour it into a cup, it is still the same volume. So it has a fixed volume. But what about gases? Remember that gases will fill up any volume they are present in. So if you have particles in a balloon, when the balloon bursts, the gas spreads all over into a larger volume. So gases do not have a fixed volume. Which one has a fixed shape? Of course, solids have a fixed shape. But the liquid takes the shape of the container, the gas takes the shape of the container. Okay, so let's take a look at some of the questions. So this is a question. It says, in which of the following are the particles arranged in a regular pattern? Do you remember? We said if we have solids, liquids, and gas, the one that are arranged in regular rows is which one? It's the solid. So the question is, which of these is a solid? Of course, if he says a gas or a liquid or a metal, you should realize that the metal is a solid, so the particles will be arranged in regular rows. The diagram shows a cup of tea. Which row describes the water particles in the air above the cup compared with the water particles in the cup? So he's comparing particles of a liquid to the particles of a gas. So if he's saying, what are we saying about the particles in the air? Is it moving faster? Yes, of course, the particles in a gas, we said, will move faster. What about closer together? Will the gas be closer together? No. So my answer would be B. Can you see that? Okay, another question says 4 statements about the arrangement of particles are given, and the question is which statements describe the particles in a solid. So we're talking about solid, liquid, or gas, and he's saying which statement is correct for a solid. So let's take a look at the statements. The first one says particles are packed in a regular arrangement in a solid. Yes. Particles are randomly arranged in a solid? No. Particles move over each other in a solid? No, we said the particles move over each other in liquid, not in a solid. Particles vibrate? Yes, that's how particles move in a solid. So the one that is correct is 1 and 4. 1 and 4 means my answer is B. So this is another kind of questions. He's saying describe the arrangement and motion of molecules in what? In a gas. How are the particles in a gas arranged? We said in a gas the particles have random arrangement. What about motion? So if he's asking about arrangement, don't talk to him about motion. If he's saying motion or movement, how do the particles in a gas move? It is a free, random motion. You could also say that it is fast, random motion. Describe the arrangement and motion of particles in copper sulfate crystal. Now, it doesn't matter copper sulfate or any other compound, but in a crystal, that's in a solid. So in any solid, the arrangement is regular rows. Movement or motion of particles in any solid vibrate in fixed position. Describe the arrangement and motion of particles in liquid stearic acid. Well, it doesn't matter what stearic acid is if you don't know what it is. All he's asking about is arrangement and motion of particles in any liquid. So in arrangement in any liquid, random arrangement. Motion, move around each other or slide over each other. Okay, another question. In which substance are the particles furthest apart at room temperature? Well, if we look at solids, liquids, and gases, you know that the ones that are furthest apart would be the gas. So the question is, which of these is a gas? You should know that ethanol is a liquid. Methane is a gas. Salt and sugar are solids. So in which substance are the particles furthest apart? In the gas, which is methane. At room temperature, in which substance are the particles furthest apart? Again, what is hydrogen? Hydrogen is a gas. Water is a liquid at room temperature. Magnesium is a solid. Magnesium oxide is a solid. So at room temperature, which substance are the particles furthest apart? That's the one that's a gas, and that is hydrogen. Some students are asked to describe differences between gases and liquids. 3 of their suggestions are these, and he's saying which suggestions are correct. So basically he wants which of these statements are correct when we're comparing gases and liquids. So the first statement says gas molecules are further apart. Is that correct or wrong? Yes, if you look at the particles of a gas compared to a liquid, the gas molecules are further apart. are gas molecules smaller than a liquid? Remember, if he's saying molecules are smaller or molecules are larger, no. The molecules do not change their size when they move from liquid to gas. They remain the same size, they don't become smaller or bigger, they just move further apart. Now, he's saying liquid molecules vibrate around fixed positions. No, we said which ones vibrate. The ones that vibrate are the solids. So which suggestions are correct? It's only the first one, so my answer is A. Which row describes the spacing and arrangement of particles in a solid, a liquid, and a gas? Again, if we remember, solids, liquids, and gas. First of all, for a solid, my options are they are close together and randomly arranged, or they are close together and regularly arranged. Remember that for a solid, they are close together and regularly arranged. So my answer is C or D. Then, liquids are what? Liquids are close together and randomly arranged, and gas is far apart and randomly arranged, so my answer is C. The arrangements of particles in solids, liquids, and gases are different. Which statement about the molecules in ice, water, or steam is correct? Remember that ice is the solid form of water. What we call water is the liquid form, and steam is the gas form of water. So which of these statements is correct? He's saying the water molecules are on average closest together in steam. No, steam is a gas, so that's wrong. The water molecules are on average furthest apart in water. No, water is a liquid. The molecules of water should be further apart in the form of steam or in the form of a gas. The water molecules in steam have the second highest average velocity. We said which of these moves faster? Velocity means movement. Which one moves faster? Remember, the molecules of a gas are the fastest, so they're not the second highest, they're actually the highest velocity. The water molecules in ice are able to vibrate? Yes, because ice is the solid form, and we said molecules in solids vibrate. In which state does 1 decimeter cubed of methane contain the most particles? So we have a certain volume. In which of these will this specific volume of 1 decimeter cubed have the most particles? Remember that if we have the most particles, that means I want the particles to be nearer to each other, so that in that volume I will have more, because as we become liquid and gas, the same volume will have less molecules. So which of these has the more particles? Remember, if I have a gas at 100 degrees Celsius, that is a higher temperature than gas at room temperature. So actually the one at higher temperature will have even less particles. The gas at room temperature will have still more than the high temperature, but the one that will have the most is the solid. So my answer here is D. You should know that pressure of a gas is due to particles hitting the inner surface of the container. So if I have particles, remember the particles are constantly moving and they're hitting each other and they're hitting the walls of the container. Now, when temperature of the gas is increased, so at higher temperature, the pressure of the gas also increases. This is because when we heat it, the particles gain more kinetic energy, move faster, hit the sides of the container faster and with stronger force. So when we have particles in a balloon, you know that when the balloon is put in the sun, for example, at high temperature, the particles will start to gain kinetic energy, move faster, hit the sides of the balloon faster, and eventually the balloon becomes larger and it will burst. So let's take a look at this question. Which row represents the particles of a gas colliding most frequently? So when will particles of a gas collide most frequently? If we're talking about pressure, they will collide more frequently at high pressure or at low pressure. You should realize that at higher pressure, you're pressing the particles nearer to each other, so the particles will tend to collide with each other more, so I need to choose high pressure. What about temperature? At high or low? We said at high temperature, the particles have more energy, so they're moving faster, so they will collide more frequently. So this happens at high pressure and at high temperature. Let's talk about change of state. So if I have a solid, what should I do to the solid to change it into a liquid? I should heat it. So when you heat a solid, or when you leave a piece of ice at high temperature or at room temperature, it will start to change into a liquid. This change from solid to liquid is called melting. So if we say what is meant by melting, melting is the change of state from solid to liquid. What is meant by melting point? Remember, we have melting happens at a specific temperature. This can be referred to as melting point or melting temperature. So melting point or melting temperature is the temperature at which solid changes to liquid. What if we're changing, so from solid to liquid is melting. What if I continue to heat the liquid? And remember, we're heating. From solid to liquid, I need to heat it. I need to give it heat. So if you remember what exothermic and endothermic means, endo means the reaction takes in heat. So I am heating the solid, so this is an endothermic reaction. It becomes liquid. I heat the liquid, it becomes a gas. Now, what does that change of state, what do we call it? We call it boiling. And this boiling is the change of state from liquid to gas. But remember that we could also call it evaporation. So you need to distinguish between boiling and evaporation. Boiling is the change of state from liquid to gas at a fixed temperature. Remember that boiling happens at a specific temperature, which we call the boiling point or the boiling temperature. So this is the temperature at which the liquid changes into gas. But we can also have evaporation, and you know that evaporation is the change from liquid to gas also, just like boiling, but this happens at any temperature, not at a fixed temperature. And it will occur only on the surface of the liquid, while boiling happens all over the... Okay, so heating a solid to liquid, this is melting. When liquid changes into a gas, that's boiling. What if I cool the gas so that it becomes a liquid? That is called condensation. So if we say what is meant by condensation, it is the change of state from gas to liquid. Cooling the liquid to form a solid, that is called freezing. So freezing is the change from liquid to solid. Some substances, when they are solid and we heat them, they change directly into gas. This is called sublimation. So sublimation is the change from solid to gas or gas to solid without passing through the liquid state. So if we look at this question, the three states of matter are solid, liquid, and gas. And he drew solid, liquid, and gas, and he wants to know what is X, Y, and Z. Please pay attention, where is X and where is Y and where is Z. What is X? X is the arrow going from liquid to gas. Change from liquid to gas is boiling. You could say evaporation, but we usually say boiling. Now, from gas to liquid, that's cooling the gas changing to liquid, that is condensation. And from liquid to solid, that is freezing. What are the processes W, X, Y, and Z in this diagram? Again, pay attention to the direction of the arrows. So W is going from what to what? From solid to liquid. Solid to liquid is melting. So my answer is C or D. What about X? What is X? X is from liquid to gas. Again, we said from liquid to gas, that is boiling. So my answer is C. From what is Y? Can you see what is Y? Y is from liquid to solid, so that is correct. That's freezing. And Z is gas to liquid, and that is condensing. The diagram shows a kettle of boiling water. As the water vapor cools, it turns into droplets of liquid water. The change of state when vapor changes into liquid, this is from what? From vapor, from gas to liquid. Can you see from gas to liquid? That is condensation. The diagram shows how the arrangement of particles changes when a substance changes state. Which change of state is shown? Well, what does he have? He has what? A solid going to gas. So that is sublimation, and that is D. Diagrams R, S, and T represent the three states of matter. Which change occurs during freezing? What is freezing? Freezing is change from liquid to solid. So which one is liquid to solid? That is B. Okay. When iodine is heated, it turns from solid to gas. What is that called? Solid to gas, that is sublimation. When liquid ammonia is cooled, it turns into a solid. So this is liquid to solid, that is freezing. When ice is heated, it turns into water. Ice is solid, turns into water, that's a liquid, that's melting. So my answer here is which one? It's D. Can you see how we're choosing the answers? Okay, diagrams of the three states of matter for carbon dioxide are shown. Which two diagrams show the states of matter before and after sublimation? What is sublimation? Sublimation is from solid to gas. So which of these is solid and which of these is gas? You can see that solid is 3 and gas is 1, where the particles are very far apart. So please notice that he could rearrange the boxes any way he wants. The sublimation is from solid to gas. Which of these is solid? The one where the particles are regularly arranged. So that is 3. To 1, where the gas is particles far apart. So that is sublimation. Now, when he asks what happens during melting or what happens during boiling, remember, for something to melt or to boil, we need to heat it. So what is happening when we heat these particles? If he says what's happening during melting or what is happening during boiling, well, the substance is heated. So what happens? Particles gain kinetic energy, move faster, overcome the attraction forces between them, and move further apart. That's how we explain what is happening during melting or during boiling. You're heating the substance, so the particles gain kinetic energy. When they gain kinetic energy, they move faster, in that order. And when they move faster, then they can overcome the attraction forces between them and move further apart. So what happens during condensing or during freezing? Of course, the liquid is changing to solid, for example, so that is freezing. You need to cool it. So when a substance is cooled, particles lose kinetic energy, move slower, and come nearer to each other. Okay, this is how you explain what is happening. So this is a question. Heating a liquid causes it to become a vapor. What happens to the molecules of the liquid during this process? So if I'm heating the liquid and becomes a gas, will the molecules become bigger? Again, we said the molecules never become bigger or smaller. So my answer is C or D. Okay, then the molecules will move further apart if I'm changing from liquid to gas or to vapor. Yes, so my answer is C. Describe the changes in arrangement, movement, and energy of the particles when the liquid wax cools to become a solid. So, liquid anything cools to become a solid. What is the change in arrangement, movement, and energy of the particles? Well, you should realize I am cooling the liquid and it becomes a solid, then the particles are losing kinetic energy. So the energy will be less in the solid. They will move slower, so that is the change in the movement, and they will come closer to each other and become regular arrangement in rows when they become a solid. So this is how you explain, and please notice that you need to explain each part of the question: arrangement, movement, and energy of the particles. So they lose energy, you're cooling it. You're cooling a liquid to a solid. They lose energy, so that's the change in energy. They move slower and they come closer to each other and become regular arrangement in rows. Which process causes the greatest increase in distance between particles? So, which one will cause the particles to move away from each other with the biggest distance? Of course, if we're changing from solid to gas, then the particles have moved away with a greater increase in distance. So my answer is sublimation. Pure water boils at 100 degrees Celsius. What happens to the water particles when water boils? Again, if I am boiling water, will the particles gain energy or lose energy? We're boiling it, that means you're heating it, you're giving it extra energy, so the particles gain energy. And then they will move from liquid to gas. So will they move further apart or stay close together? Well, they will move further apart. So during boiling, the particles gain energy and they move further apart and become a gas. 4 physical changes are listed. In which changes do the particles move further apart? Again, which of these will cause the particles to move further apart? Condensation, can you see where condensation is? No, the particles move nearer. Evaporation, evaporation means from liquid to gas. Yes, they will move further apart. Freezing, freezing is from liquid to solid. No, they're moving nearer. Sublimation, from solid to gas. Yes, they move further apart. So my answer is 2 and 4. So that is C. Are we following all of this? Okay. In most questions, or in some questions, he will give you certain melting point and certain boiling point and ask you, is the substance a solid or a liquid or a gas at a certain temperature? So, for example, if we know that something is a solid at room temperature, and remember, room temperature is taken as 20 degrees Celsius or 25 degrees Celsius. This is what we refer to as room temperature. So, if something is a solid at room temperature, what does that tell you? It tells you that at room temperature, it hasn't melted yet. And that means its melting point is higher than room temperature. And the boiling point is always higher than the melting point. So if the melting point is high, then the boiling point will be much higher. So if he gives me a substance, A, for example, whatever, and he says the boiling point is high and the melting point is high, then at room temperature, that substance is a solid. What if a substance is a liquid at room temperature? That means at room temperature, it has already melted, and that means we have passed the melting point. So the melting point must be low, lower than room temperature. But it hasn't boiled yet, so the boiling point is higher than room temperature. So if something has low melting point, high boiling point, then at room temperature it is a liquid. What if something is a gas at room temperature? That means it has already melted and it has already boiled, so that means at room temperature we have passed the melting point and the boiling point, and that means that it has very low melting point and very low boiling point. Are we following? Okay, so let's see this question. The melting points and boiling points of 4 substances are shown. Which substance is a liquid at 100? He's not asking at room temperature, he's asking at 100. Now, for something to be a liquid at 100, what does that mean? We said that means its melting point is lower than 100, but its boiling point is higher than 100. So which of these has melting point lower than 100 and boiling point higher than 100? A has very low melting and boiling points. That would make it a gas at 100. B has low melting point and its boiling point is lower than 100, so it will also be a gas. But C, it has melting point low, boiling point high. That means it's... Okay, then the next question says a compound X has a melting point of 71 and a boiling point of 375. And that means that above 71, it's a liquid. Until 375, that's the boiling point, so above 375, it's a gas. And the question says which statement is correct. So, it's a liquid at 52. At 52, it has not reached the melting point yet. So, it has not melted. So, actually, at 52, it's still a solid. Now, the next choice says it's a liquid at 69. No, it has to be a liquid above 71. So if he says it's a liquid at 75 or at 80, that is correct. So my answer is C or D. Now, in order to be a gas, it has to be above 375. So that means my answer is D. The melting point of 3 related compounds are these. The boiling point of all these compounds is above 100. Give the physical state of each acid at room temperature. First of all, we don't care what capric or formic or palmitic means. We just have 3 compounds, and he's given me the melting point of each of them. So, capric acid, he says the melting point is 32. So, the melting point of capric acid is 32. And the boiling is 100. So, all of them above 100 are gases. At 32, if the melting point is 32, that means at room temperature I have not reached the melting point, and that means it hasn't melted yet, so that means it's a solid. What about formic acid? Formic acid has a melting point of 8. Now, that means by the time we reach room temperature, it has already melted, so it's a liquid. What about palmitic acid? The melting point of palmitic acid is 63, and that means at room temperature, it has not melted yet, so it is a solid. Substance L melts at -7 and is a brown liquid at room temperature. Which temperature is the boiling point of pure L? So, pure, first of all, means it should have a specific melting point. So, B and D are wrong. You cannot boil over a range unless if there is impurities. But a pure substance should have a fixed boiling point. So, the question is the boiling point minus 77 or 59? Well, you should realize that it melts at minus 7. And that means its boiling point should be higher. Remember that minus 77 is lower than minus 7. So, it melts at minus 7. It's a liquid at room temperature, and that means its boiling point must be higher than room temperature. So, that is 59. That's reasonable. Then we have a heating curve. A heating curve means I am following the change in solid, liquid, and gas as I increase the temperature. So if I start with a solid and I'm heating it, that means the temperature of the solid is increasing until I reach a certain temperature, which is the melting point. Now, during melting, the temperature does not rise because the increase in heat or the increase in energy is used to change the solid to liquid. So during melting, the temperature does not increase even though we're still heating the solid. Until everything becomes a liquid, then the temperature starts to rise. Now, the temperature of the liquid will continue to rise until we reach the boiling point. At that temperature, the liquid will start to boil and the temperature remains constant during boiling until everything changes into a gas. Then the temperature of the gas will continue to increase. So this is called a heating curve. Remember, the flat areas in the curve represent the change of state, whether it's melting or boiling. When the temperature is rising, that means you're heating the solid or the liquid or the gas. Now, what if I start with a gas and I cool it? Now, when I cool it, the temperature decreases. It will continue to decrease until we reach a temperature at which condensation happens. Remember that a substance will condense at the same temperature that it boiled. So if I say the substance has a certain boiling point, it is the same as the condensation point. So the gas is changing into a liquid, that is during condensation. That's the flat area in the curve. Until all of it has become liquid, I continue to cool, so the temperature of the liquid will go down until we reach what? The freezing point. At a temperature, it will start to freeze. Now, while it is freezing, the temperature remains constant until all of it has become a solid. Then the temperature will start to decrease. Please remember, the condensation point is the same as the boiling point. The freezing point is the same as the melting point. So if a substance has a certain melting temperature, or it melts at a certain temperature, it will freeze at that same temperature. So this question says a solid metal is heated until it turns to vapor. The graph shows the temperature of the metal during this process. Which part of the graph shows the melting of a metal? A metal means I'm starting solid. So that means, where is the solid? The solid is at A until it starts to melt, and that means it is melting at B. Remember, the flat area after a solid, that's the melt. The diagram shows a heating curve. Is X solid, liquid, or gas at room temperature? Where is room temperature? Room temperature is 20, so 20 is between 15 and 80. Remember that this graph says that 15 is the melting point, 80 is the boiling point, so at 20 it has already melted, it is a liquid. Name the change of state which occurs in D to E. Remember that. It started as a solid at A. Now at C, it has become liquid. Now at D, it is doing boiling. It is changing from liquid to gas. Explain how the curve shows that a pure sample of compound X was used. Remember we said, if something is pure, it will have a fixed, sharp melting point and a fixed, sharp boiling point. Now, what if it were impure? If it were impure, then it will melt over a range. So this area B, C, or D, E will be a bent line between two temperatures, and it will not have a fixed melting point or a fixed boiling point. Okay, we're going to stop here now, and next time we're going to continue talking about diffusion. Okay, thank you for listening, and please continue listening to the videos. We will be doing all the chapters according to the new syllabus in the IGCSE.